Welcome back to part two. In part two, we're going to talk about Bob. He ate 34 hot dogs in 10 minutes during a contest. All right. What is his rate of change? Again, we can often think about that as what was the speed. Okay. Well, what we know is he had 34 hot dogs in 10 minutes. Our question is, how many hot dogs is that in 1 minute? Like we did with Caroline and her bike ride, we could do cross products, or in this case, we could simply take top divided by bottom, because we're going down to the unit rate of 1, and do 34 divided by 10. That would tell me he could eat 3.4 hot dogs, label your stuff, per minute. So 3.4 hot dogs per minute. My apologies. Okay, just like Carolyn, we're going to have time here because time is your independent variable. That is something we cannot control. Things you cannot control are always your x's. We will always start at time 0. So before the hot dog eating contest, at time 0, Bob did not eat any hot dogs. Okay, remember this. Bob ate 3.4 hot dogs per minute. That means in 1 minute we did this. Well, we have to think, oh boy, we are going by 2 on this one. So we're going to add 2 there. Well, let's just get the hang of it. So I'm going to add a little column here. If I was going to say then after 1 minute, how many hot dogs would Bob have eaten? 3.4. Then to get from the 0 to the 1, we added 1. And then the next minute, he would be able to eat another 3.4 hot dogs for a total of 6.8 hot dogs. Okay, now that we know what we did is we just kind of took this and then we doubled it. Let's think about this. So if in 2 minutes he can eat 6.8 hot dogs, if I add 2 more minutes and I go here and I add 2 more minutes of eating, would I add 3.4, or do you think I should add the 6.8? We're increasing this by 2, so we should use the data from the 2. So I would add 6.8 because in 2 minutes he can eat 6.8. 6.8 plus 6.8, you definitely may use a calculator, 13.6 hot dogs. Oh, again, we're doubling that. So we didn't talk about 1 minute of eating 3.4. Instead, we're working by plus 2. We know that in 2 minutes, he is able to eat 6.8. So he would have had 20.4 hot dogs eaten. What I'm going to do a little different than I did on the last video, I am going to ask you to pause this video, and I mean literally hit the pause key or button, and I want you to finish this table but don't go any further, and we will compare answers. Please hit the pause button, take a couple minutes, finish the table. Let's make sure we get the same answers. Thank you for pausing the video. I appreciate that. Let's take a minute and look at our answers. Again, I knew I couldn't count by 1 because in 1 minute he did 3.4, but we're counting by 2s, so I had to keep adding how many hot dogs could he eat in 2 minutes? 6.8. add another 2 minutes, 6.8, and I ended at 34, which is I know the total he had. A little different than Caroline, where we just counted by ones. This time we had to extend the table, do a little thinking. In 1 minute, we would do 3.4. We could have added the third one here. We could have added the fifth one and filled in the blanks, but we're going to count by twos. All right, let's look at our graphs. We're going to need to set them up. We have to label the X and Y. Remember, the table always kind of helps us know what to write on the X and the Y axis. So again, on the bottom, we're going to have the word time. This time it was in minutes. Over on the Y, it talked about total number of hot dogs eaten. I always leave myself a little space so I can squeeze the numbers in where they need to go. Again, we're going to do some skip counting, but 0 goes in the corner, always. And then I'm going to do skip to 2, skip to 4, skip to 6, skip to 8, and skip to 10. For the Y, I have to be able to cover all the numbers from 0 to 34. So I'm going to have to do some thinking. I know I can't count by ones. 1, 2, 3, 4, 5, 6. I would never make it to 34. Excuse me. If I counted by twos, 2, 4, 6, 8, 10, 12, 14. Nah, I would never get to 34. Let's see. Counting by threes is kind of weird, and fours. So I'm going to try 5, 10, 15, 20, 25, 30, 35, 40. Oh, that gets me there. It almost has me fill up all the lines here. So I will do counting by fives. But what I like to do when I label my graphs and make it easier for me, we could label every one, 5, 10, 15, 20, or we do that skip counting. I really am still counting by fives. I just am not labeling every horizontal line. You do what works best for you. Okay. Now I'm going to ask, what was our interval really? What did we really count by down here? If I go from 0 to this line, how much is it? And then to here, I really counted by ones. I didn't label everything. This would be 1, 2, this is my missing 3, 4, that would be my 5, etc. If it's helpful to you, you label every line. Here, my interval, what I counted by, were fives. Okay. With decimals, when it comes time to graphing, we're just going to have to do our personal best. It's hard to be 100% accurate, but I do know that at the beginning, before the contest, let's say, started, he hadn't eaten any hot dogs. We know that after 2 minutes, he was able to eat 6.8, so that's above the 5, but closer to the 5 than it would be to the 10. After 4 minutes, he ate 13.6 hot dogs. So here's 4, here's 10, here's 15. So that's right almost in the center. We're going to do our best guessing again. It's very hard with the decimals. After 6 minutes of eating, he is at 20.4. So that is just above the 20. 8 minutes, we're at 27.2. So here's my 25. 27 is kind of right in the middle of 25 and 30, so I'm just going to plop it there. And finally, after 10 minutes, he almost ate 35. He was able to eat 34. So I put the dot just a little below my 35. Do the very best you can to draw your straight line. I have found if you move your entire hand and not just your wrist, it works better. Slide your entire hand to draw the line as opposed to just flinging your wrist. Okay. A few things I want to talk about on this one too. We could call this one linear. One thing that I know with the word linear, it has the word line in it. Our graph has a straight line. Our points, our ordered pair from the table, the x's and the y's, are equally spaced again. When all of that is true, it is showing us it has a constant rate of change. Because we use decimals on this one, we could still connect two of these ordered pairs, but it's very, whoops, I went too far. It's very hard to show that these steps are perfectly equal because we had to guesstimate where we think those decimal points are. But if we connect them, it doesn't matter if you connect them below or above the line. They should look almost identical in height. That would be the constant. Please glue or tape this into your notebooks. These are your notes. We're going to refer to them quite often.